Welcome to another Emerald Hill Skies live stream from here on the outskirts of Louisville, Kentucky. You're looking at a picture of our scope that we're using. I'll just mention it's a RASA, an 8-inch Rowe Ackerman Schmidt astrograph, more like a big 8-inch camera lens that's designed for astrophotography. And it's sitting on a Skywatcher mount. And let's dive right in. Tonight's kind of a special night because it's my first night to try guiding. And I'm using PhD 2 here. You can see that it actually looks pretty good. We have a signal to noise ratio above 50. And this is not a bad looking chart here, I think. You can see that our total RMS is 0.48. I think that's pretty good. It seems like our scope is guiding really well. This is guiding off of a stellar view 60 millimeter guide scope with a ZWO ASI2600MC monochrome camera. I'm going to stop guiding now so that we can switch targets. I think I'm just going to stop this right here and head back to our planetarium software, which is Sky Safari. And I think right away, the first thing we'll do is go back to Polaris for just a second to choose this Polaris. And let's go to that.
Slewing to coordinates.
Okay. Like I say, we're in Louisville, Kentucky, and you can see up there in the upper right the live view of the actual scope that's slewing to Polaris. And what I'd like to do now, while that's lining up with the North Star, just kind of recap what we've done. We set the scope up and, of course, did a polar align. And that's
slewing complete.
Pretty fast tonight. We focused the guide camera out there by the scope because that's a manual focusing job using that actual scope manually. And then at that point, we came inside the building here. We're about 200 feet from the location of where you're viewing the scope here. Let's go to our astro planning software. It's called Astro Planner. And let's take a look at a target. And what we do here is we sort the list by what's visible and also by the altitude. And let's just take them in order. These are all targets that I've never seen before. So I often joke with people, don't look at me as a guide, look at me as a fellow explorer. We're on this journey together. So what we'll do is we'll look at this first target, which is Barnard 347. And we'll try to slew to that.
Slewing to Pier East.
Okay. And while that's slewing there, I just would like to let you see a little bit of how we did when we did our focusing tonight. And we used Nina as our autofocus software. And man, I'm really excited about they call this, the focus curve.
Slewing complete.
That we got here. Let me just look at the options here in case you're interested in this sort of thing. We chose to do 5 offsets using the half-flux radius approach for autofocusing. We chose the trends and hyperbolic as our curve-fitting strategy. We said, take it, a couple of attempts. We told it to use multi-star focus, and we asked it to use the 10 brightest stars. And then we were careful to choose a part of the sky that we thought might lend itself to really a good autofocus strategy. And what does that mean? Well, it means we picked a part of the sky that was very rich in stars. And not only rich in stars, but that was fairly balanced. There wasn't like a nebula or a galaxy there that might throw off the autofocusing. We use as our target the same target I've been using when I work on the tilt and the back focus for this RASA telescope. And that is a random star that we found in the middle of a very rich star field near the star Sadr, S-A-D-R, but so that Sadr is not in the field. It's a very bright star, you know. So the target is HD 192911. I think we ought to make that star famous because if you line up with HD 192911, just a random, you know, a random everyday star in the middle, then at 3 degrees, the full RASA star field with this ASI 2600 MC Pro. It's a ASC, it's a large framed camera. It ends up that even with a 3 degree star field, you see all these evenly lit stars. So what that did is it gave us a nice batch of rich stars. It picked out the 10 brightest there. We gave it 10 seconds of autofocus exposure time, which is a little bit long, but I think what that did is it let us see all those different stars at no matter how dim or how bright they were. We also tonight we told uh, Nina to look at the central part of the frame. That way, if our corners did have just slightly out of focus stars or slightly, and they're not bad. They're a lot better than they used to be, but they're not quite perfect yet. They're a little bit elongated. By using a number less than 1, we cropped our APS-C full frame camera and told Nina to just use the center of the frame. I really think that helped us because you can see when we did the actual image then, it ended up that we ended up with a lot better curve than we've ever seen before. And I'm hoping this will give us really tight pinpoint stars. So I'll tell you what let's do. Let's go up to our equipment and let's disconnect the focuser and let's go to the camera and disconnect the camera. And what that'll do is allow us, I'm just going to go ahead and close out of Nina, I think, and instead we're going to open up SharpCap. And see, did I already have SharpCap open? I think I did. So now I've opened up a second instance of SharpCap. So let me close that one because we did already have it open right here. And let me open that up for you so you can see that. And what we'll do is we'll open up our camera in that frame. And this is my first time to see whether or not our stars ended up being in focus using that autofocus in Nina. There we go. Oh my goodness, look at those. Those are beautiful, nice and round stars. I'm just gonna go right to the corners here so that make myself really vulnerable and go to 100%. Look at those beautiful star shapes. Thank you, Lord, for giving me those 4 nights to work. So here we're at the upper right edge, and really, I mean, those are not elongated very much at all. If you study them, maybe they're not quite as pinpoint, but they're not bad. And down here the same. There are no trails. There are no funny little shellfish looking things. Now here we do have, look, a little bit of elongation in the lower left. So that's something I'll have to work on. Our tilt is about 12%, and our back focus now is about 27%. So you see it's not perfect, but using this new camera holder that we got from, it's a beta version from Octopi Astro, we have radically improved. And look, here we are in the upper left, and again, these are just barely, you can see barely some elongation, but this is at 100% zoom in a very large frame camera. And going to the middle of that at 100%, you can see that we now have this pinpoint star shapes. I'm so excited about this. This is such an improvement. So let's drop back to the full frame now. And let's get our number again. It's Barnard 347. So let's put our target name in here. Barnard 347, and then let's just check our positioning using a plate solve and sync. Now this is actually our first plate solve of the night after we, polar aligned and we're just getting started. And typically after the first plate solve, when we slew to the target, we will be a little bit off. And it just varies, uh, I don't know, randomly based on how far off you are, I guess, because, we're not doing any kind of auto star alignment that you might think of with a typical Celestron product. They tell you to auto align on 3 stars, and we're not doing that at all. We just do a polar align, and then we tell it to slew.
Syncing to coordinates.
We're just
Slewing to
1.86
coordinates.
degrees off, and my
Slewing
experience so far
complete.
is that on the next targets, we won't be even 1.86 degrees off, because what our ASCOM specialty software does, and we use a specialty ASCOM software called GS Server, and stands for Green Swamp Server. When we do this plate solve and sync, it compares your sky shot from your camera with its library of stars in sky shots, and it finds a match to the exact bit of stars, and then what it does is it overlays the two and matches them, and it moves the scope to where it should have been by 1.86 degrees, and then it tells the ASCOM software, Green Swamp Server, that it needed to kind of correct the model a little bit, and you'll notice the rest of the night it seems like our solves are a lot more accurate, and we're going to be off a lot less the rest of the night. Now, the next thing we want to do is we want to start our live stacking, and you know what that is? That's when you begin. Wait, I want to do one more thing before we start live stacking. Let's adjust our exposure a little bit, because 3 seconds at 350 gain, that sounds like a lot of gain. Oh, let's try it. Let's try 3 seconds at 350 gain and just see what we get. We might have to change that. Anyway, while that's collecting some frames, I want to do one other thing. I want to go, see, back over to our guiding. You know what? Let's start that before we live stack. How about that? So I'm going to stop the live stack process. And let's go back over to guiding, because I need to get used to this now again. Let's see. Auto select star. Okay. And I did a calibration in PhD2, so I don't think I'm going to calibrate every time we slew. I think I calibrated once. I think I'm going to let that be good for the night. So now that's guiding. Now let's change this exposure. Let's make this more like, Barnard 347. I don't even know what it is, but let's do maybe 20 seconds, and let's drop the gain to maybe, I don't know, 200, something like that. And let's let that maybe collect 1 frame, and just make sure we can see the stars well here. So keep in mind now, since we're guiding, we're guiding on stars, auto guiding, and that's helping us stay in sync with the stars. And it's using a completely separate imaging train for that now. And this is my first time to try this. So that's the frame. I kind of like that. We're not seeing whatever Barnard is, Barnard 347. But let's start our live stack process now. And we'll clear what we had before so we can start from scratch. So that's going to wait. Now, while that's collecting its first exposure, why don't we go to our Sky Safari planetarium program, and let's look up this Barnard 347. So we're going to say search for Barnard 347. Just try it like that. Okay, it found it. It's a dark nebula appearing in the constellation Cygnus. Not a lot about it. There's no like narration or anything. Let's center on that. And then let's zoom in. Okay, so this is in this object. I was just looking at this the other night. Uh, this is in this very large nebula called, what is this nebula called? Let's see if we can make it select. There we go. IC1318. It's a very large nebula, and Barnard 347 is some of these dark patches that we see here. So we should be roughly aiming at it there. Look at it, the way it's getting closer and closer to the meridian. That's going to be so interesting, isn't it? When the telescope reaches the meridian, I think I let it go about maybe 10 degrees past the meridian. So we don't have forever here. Let's go back to sharp cap stream. So now let's, but that's our first stream at 20 seconds. Now let's go ahead and do a quick little auto balance of the color. That helped us a lot. Let's move this black level right here. And then, you know, our mids are not bad. Look how we're getting a little bit of grain here. It's just the first image. Some of that grain will kind of disappear as we collect other subframes and SharpCap starts averaging them together for us. The Barnard 347 is that dark nebula right there in the center. We can help this a little bit by increasing our exposure, I think, to 30 seconds and lowering our gain to 100. This is kind of a sweet spot for this camera, and that'll help us all the more get rid of that grain all the more. This camera has a particular setting around 100 gain. It's just like it kicks in this special circuitry that makes the camera really enjoy whatever it's seeing there. So now we've got 2 frames. Our auto stretch still looks good. Let's do another color balance here. Still looks pretty good. Let's just squeeze as much as we can out of our mids. Let's move that just a little bit and see how we do. Okay, that's good. Now let's zoom in a little bit on this dark nebula. That's this dark nebula. Now, you might be wondering what causes a dark nebula. Well, as best we understand it, it's just a collection of dust that is covering up the hydrogen gas that we're seeing in this nebula behind it, and it's being lit up, by the way, and ionized by that star, SADR. SADR is the proper name for that star. And as the electrons excite and ionize this hydrogen and make it glow in the dark, so to speak, then what happens is this dark nebula begins to glow all the more. Snapshot captured, save exactly as seen. Now let's go back out to our observing, our astro planner, which is our targeting software, is also what we use for logging. So we'll make an observation and we'll say first time guiding for real. I did test guiding once, but it wasn't working correctly. It's been several weeks ago, and so this is my first time to actually try to use it. It was near the meridian, so that'll kind of help us understand what happened in this and lost the star, the guide star, something like that. And then I'll say, meanwhile, the dark nebula, Barnard 347, looked great. Still looked great, something like that. And then we'll go up here under attachments, and we'll add that file that I just made. Barnard, and that puts it in the then I'll also add No, let's don't worry about adding the big images tonight. That's good enough. Let's go back over here now and see how the image that comes, that's just a little bit off camera for you, isn't it? Let me see if I can bring that inside your frame. No, it's not going to show it correctly, is it? Oh yeah, there you go. So you see how it doesn't really have an image of Barnard 347. So what we'll also do is right click here and say add user image. And then we'll load that image bar, and I think this might be off camera for you. And we'll say something like dark in the middle, dark in the middle of the glow. And so that just gave it a name. So now see, we'll have actually an image of that dark nebula, and that'll help us for next time. So let's save that. Okay, so that's a complete cycle. And again, that was our first time guiding. Let's do another sort. And look now, it says this Be37 is the next target. And that's at 68 degrees altitude. See the little altitude line there? Let's go ahead and slew to that.
Slewing to coordinates.
So we're going to something that's about 68 degrees. It's Be37. You can see the scope moving up there in the upper right.
Pier west.
What I love about having this WISE 3 surveillance cam is that it has an infrared light built into it that's invisible to our naked eye. And so trying to think of how to show you that little WISE cam deal. Let me do it this way. If I show you a picture, yeah, this is a picture of the RASA, and I took this a night or two ago observing. But can you see right here in front, in the foreground, that little object? And I wish I had something there to show you the reference of the size. That camera is about, it's about the size of the top of this water bottle. It's a tiny thing, just like a children's building block. But it's got a little easel built into it, and it's aimed up at the scope. And you know what's really odd is that it has no lighting at all. In this image, you can see that the telescope looks red. That's because I had some red lights trained on it. But in this image that you're seeing here in our actual planner in the upper right, there's no red light at all. That's just the infrared. And when you look outside 200 feet away where the scope is, it's just pitch black out there. So the scope is kind of invisible to the naked eye right now. But to this WISE 3, it lets us keep an eye on the scope, and that's good for security. But it also lets us maintain a connection with the sky. So we can kind of see, oh, so that's where the scope is pointing. It lets us kind of see where the scope is in relation to the sky. Okay, so now we're aimed at Be37. So let's go back to SharpCap. And let's stop the live stack, by the way. Let's put in the new name of our new target. It's Be37. I have no idea what this image is. Be37. Remember, we're explorers. I think I'll capitalize that. Be37. Okay. Now let's do a plate solve. That's odd, isn't it? The way it went to the real image. Oh, that's because we have the exposure set at 30 seconds. Let's go back to something like 5 seconds and put our gain at, I don't know, 300 or whatever. And let's do our plate solve there. And I kind of think that the plate solving happens faster, doesn't it, when we're using these shorter exposures. And there are plenty of stars there in the image to be able to let it find, right? Let it find the image. like I say right now, it's comparing. Look at it. It's downsampling. In other words, this camera has such a wide, uh, it's APS-C. There's so many pixels that it has to downsample to be able to compare it to its database anyway. And then right now it's comparing it to stars, and it's comparing it to lots of different pictures, and it's mosaicing all those together, and then it's trying to find out exactly where we're pointing in the sky, hoping to make an exact match, you see. And boy, the longer it takes, I always get more and more nervous here. Is it going to be able to do a match? It did not solve there, did it? So is it going to be able to find a match? Taking a long time. I wonder if I set the exposure too short for it to be able to find a good match. BE37. What is BE37 anyway? Yeah, so maybe that, but we're looking
Syncing
here.
to
Oh, it
coordinates.
found it, and it's just a quarter of a
Slewing to
degree off.
slewing
In
complete.
spite of the fact that our scope was hanging backwards over the meridian. In other words, it was leaning so far back that the weights were up a little bit instead of what you want usually for the weights to be down. That took it a long time to find a good match. But it did, after all. It finally did. Now, let's go ahead and change our exposure now back to 30 seconds. I kind of like that 30-second mark. And let's put it at 100. BE37. IC1396. Let's search for that. IC1396. You think it's the Elephant Trunk Nebula? I think this is misnamed. So the Elephant Trunk Nebula is in this extremely large cluster. It's awash with a faint nebulous background mixed with dark lanes. At its center is the bright triple. The nebulosity sprawls across 3 degrees of sky. Wow. It says it's difficult to see visually, but it makes spectacular photographs. Wonder how long a typical photograph would be. Jim Misty did a good job there, didn't he? All right, so this is going to be something we're going to have to pull out. Let's go back to SharpCap. And we're at 30 seconds at gain 100. That's actually a good setting for something that's very faint. Let's do another color balance now that we have some more frames in. Darken up that sky a little bit. And now let's kick up our mids. See if we can start. Now see, I think we might be starting to see a little nebulosity there now, right? See there in the middle? And look, there are some dark lanes. This is after just 6 minutes. So I think this is a tougher target. Now, I wonder if this BE37 is true. Let's go back out to the web and look at IC1396. So we're going to go back out to the web. That's there. And now I'm going to go to that in my browser. And let's see. Was it 1396? Is that what it was? Just beautiful, isn't it? IC1396. So let me ask you a question. I don't see the BE anywhere there, and in fact when we looked in BE in that must be a different name in our Astro BE37. So let's in our browser, let's look for BE37 Nebula. I wonder if it's from the Barnard catalog. So, oh look, I misspelled. Barnard 37. Here we go. It's a dark nebula, and it's in the constellation Monoceros. 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 Let's say wiki. There's no Wikipedia entry on it. Must not be very. Oh, there it's listed. Let's go down here to Barnard 37 and click on that. Nope, there's no article. This is a pretty random nebula. What if we went to our yep, that's what we're pointing at. Look at that. And there's that garnet star. Is that in our field of view? I bet it is. Look. Look at this. I bet this is that garnet star. Look how beautiful that is. We're definitely starting to show some nebulosity, aren't we? This target is pretty difficult for EAA, for brief EAA. This is more of a photographic target, isn't it? Visual astronomy. But look at it, it's starting to come in. And look, there's the dark nebula. I tell you what, I think we're going to see it. With 17 frames now, 18 frames. This is a real, what's it called, target. That is Barnard 37, that dark nebula. Because remember, the Barnard catalog is a catalog of dark nebula. So what you see back in behind there is this IC1396, what was it called? Elephant Nebula? IC1396. IC1396. There we go. IC Elephant Trunk. Let's look at the info one more time on that. That is a huge target. Look, it kind of reminds you of the Rosette Nebula, doesn't it, in a way, except it's outlandishly large. And fortunately, we are centered right on that dark nebula. So what this dark nebula is a bunch of dust in the front of that ionized hydrogen. It's kind of like we're looking at what's not there, aren't we? Because what we're doing is looking at dust. By the way, this dust, I did some reading on that, and it's not like the dust underneath your bed, you know, on the hardwood floor. This dust is more like soot. It's like leftover candle burn carbon that's just floating in space in front of this nebula. And it blocks our view of the nebula, see. Not sure how long we would have to... Well, that was not a very good color match, was it? Not sure how long we would have to stay on this target to get a really good image of it. Well, I don't like all that purple in there, do you? I'm going to kind of override and bring that purple down, yeah. Now let's sneak this dark back over. And bring those mids up as high as we can. And now we'll kind of enlarge this for you. That's Be37. So let's grab a picture of that. A little snapshot close-up of it. Be Barnard 37 as seen on 2021 0812. And then I'm so pleased with that. After just 11 minutes, I have a feeling to see this elephant trunk nebula correctly, it would take us like 3 hours of photography to view that. But even right now, with just 11 minutes, we are now seeing that dark nebula already. It's pretty cool, isn't it? That we're looking at a bunch of soot and dust, and that's occluding, it's hiding that elephant trunk nebula behind it that's just starting to come into view. I think I'm going to save a picture of that here at 100% because that is kind of fascinating. Look at that. That is Barnard 37 2021 0812A, we'll call it. So let's stop. Oh, wait, let's do one more thing. Let's drop that back to auto size, full frame, in other words, and do. Wait, let's darken this up first a little bit. Yeah. And save that exactly as seen. Okay. I love that garnet star in that lower right too. That's really cool. Let's stop the live stacking. Go back to our targeting software and make an observation. I have to put this on general. We'll just say, well, our view of the background nebula wasn't as dramatic. After just 11 minutes of data, we were starting to see the nebula, but it was definitely enough to make out the dark nebula, Barnard 37 in front. And then back here under attachments, let's go ahead and put this, the Barnard 37 in there. Look at that. Wow, I hope you can see that. Now let's go back here and say add user image, load the image, Barnard 37. Let's call it after 11 minutes, dark nebula. Yeah, I don't know if you can see that. That shows up over YouTube. Let's do another search. Sort. Let's go to NGC 7331. Slew to object.
Slewing to coordinates. Slewing complete.
Okay. And let's let that settle in. Wait, let's decrease this to 10 seconds and make this gain 200 for a second. And then let's do a plate solve. I don't think very many people. Oh, is it that late? Yeah, it's 1:30 a.m. Oh, look, there's a galaxy in the middle. Can we Look at that galaxy. Is that not the coolest thing ever? Wow, this is NGC 7331. Let's go back over to Sky Safari and search for that. NGC 7331. There it be. Oh, there's an audio tour. Take a listen.
NGC 7331 is a bright and attractive galaxy in the constellation Pegasus. It makes a triangle with the stars Pi and Eta, with the galaxy being in the direction of Andromeda. It's a bright and easily explored galaxy in a 60mm telescope. This is a spiral galaxy and is sometimes cited as an example of what our own system would look like from the outside. In small instruments, it's elliptical in shape, but 150mm shows the grainy texture of the dusty lanes. Photos show the familiar arms looping about the bright core. Right next to 7331 are 5 small dim objects that form a galaxy cluster and are called Stephan's Quintet. 4 of the galaxies can be seen with a 250mm telescope. The 5th requires at least a 300mm instrument.
All right, look, there's one of those galaxies in that quintet. And there's another one. Isn't that interesting that there is a quintet? Look, 1, 2, 3, 4. We're not seeing the 5th one in that picture. No. Wow, this was one of the 18 key galaxies chosen to calibrate the galactic distance scale that the Hubble Space Telescope used to obtain an accurate distance of Cepheid variables. That's pretty cool, isn't it? 1:38 a.m. That's very cool. Notice we have 6 frames stacked for a total exposure of 3 minutes, and we're already seeing these spiral arms that are throwing material out here after just 3 minutes and 30 seconds. Look, I don't have any calibration frames. It means that I don't have any darks here or flats yet in this new imaging train. I just haven't taken time to do it. So there's a blue hot pixel. See that little blue hot pixel? But these are real. There's a galaxy. There's a galaxy. Oh, wow, sorry. It's getting late. That's pretty cool. Wow, fun. Who knew that we'd be able to see, you notice in the narration it said, what was the one thing it said you would need a scope of, did it say 250 or did it say 300? I don't remember, but that's a pretty good little telescope. Ours is, isn't a RASA 200? Oh, it's F2, but I think it's 400 millimeter. Yeah, I think it's 400. Let me double check that. It's a while since I've had to know that. Yeah, 400. So we have a very wide framed camera. But look at those great spiral arms now. We're at 100% zoom, by the way. And there's a galaxy, and there's a galaxy. You think that's one? Maybe that's one there. Pretty good focus that's letting us see this nice image at 100% zoom. NGC 7331. NGC 7331. This is my first time to... No, I visited this on another night, but I didn't draw out this galaxy this well on that night. This looks a lot better. It's a lot better tonight. Okay, so there's that. So let's stop live stacking and go back to our targeting software and add user image. NGC 7331. Let's call this, let's see. Tiny galaxy. View. Okay. So thanks for joining us for this. It's obvious that God has been at work up there in that sky, painting these kind of masterpieces for us to see tonight and enjoy. So thanks for joining us for this, and we look forward to seeing you in the next one. Next time we'll be sure and send out a little warning so we can get more folks involved. God bless. Have a great evening. We'll talk to you later. Good night. For